All right, so we're looking for the area between y equals 2 over x and x plus y equals 3. So first thing we'll probably need to do is figure out where those things intersect. That seems reasonable. So y is also equal to 3 minus x. If we were to solve the second one for y, we got to find our limits of integration. And so if y is 3 minus x, then we can plug that in as 3 minus x equals 2 over x. And that will give us 3x minus x squared equals 2, or x squared minus 3x plus 2 equals 0. And that should give us our limits of integration by factoring that. Everybody good with that? What does that become? Minus 2 and minus 1. So x equals 1 to x equals 2 is where we're going to integrate. Then we need to figure out which one is above the other one on that interval. So how do we figure out which one has a larger y value? Just plug in something between 1 and 2, right, into both of these and see which thing is bigger. Wouldn't that do it? Which one's bigger? If I plug in, let's say, 1.5 or 3 halves, 2 divided by 3 halves. What is 2 divided by 3 halves? That's 4/3, right? And then if I plug in 3 halves over here, we get 3 minus 3 halves, which should be 3 halves. Which of those is larger, 3 halves or 4/3? 3 halves. So which one is above the other one? The 3 minus x. So we'll do 3 minus x minus 2 over x dx. Everybody good with that? Nick, you good with that?
Yeah, I just did a stupid thing.
Oh. I recommend not doing a stupid thing. So you integrate 3x, x squared over 2, and then a 2 natural log absolute value of x. And then you plug it all in. So you get 6 minus 2 minus 2 ln 2 minus 3 minus a half minus 0, because the natural log of 1 is 0. So what does that come out to be? 4 minus 3 is 1 plus a half, so 3 halves minus 2 ln 2. And I'm sure that the answer choice is E, is that right? Which is the same as 3 halves minus ln 4. They just took the 2 as the coefficient and brought it in as a power inside the logarithm. At least based on what the answer choices look like. Everybody good with that? Great. Wonderful. Other questions? You good with that, Nick?
Yes, thank you.
Yeah, sure. Other questions from this section? Oh, 53. Oh, boy. All right. Maybe. All right, 53 says we have a sphere with a radius of r. A sphere with a radius of r. It's divided into 2 parts by a plane at a distance h, where h is between 0 and r from the center. We want to find the volume of the smaller part. Okay, so basically we're cutting it off somewhere, calling this h, and looking for the volume of this smaller piece here. And it looks like everything's in terms of H and R in all of the answer choices. So we're just going to do everything in terms of H and R. That seem good, everybody? All right, so we're looking for the volume of, question? All right, we're looking for the volume of just this smaller piece right here. We could take the piece up above, just this piece right here, and revolve this piece right here, that's also horribly drawn, and revolve it around the x-axis. That would give us that volume. So let's pretend like this thing is sitting there on the coordinate axis. What would the equation of this semicircle up here that we're going to use a piece of be? The semicircle's equation is what? Y equals square root of radius squared minus x squared. That's something you guys should all know. And so we're going to integrate this squared, because that's going to be our radius of the circle. And then we're going to do it from where to where? Right, pi times the radius, that's the radius, right, is y squared. Where are we going from? We want this section right here. Should be h to r. Yep. Everybody good with that? Does that make sense to everyone? What's the variable in this problem? There's only one. X. We're integrating with respect to x. R, h, r squared, those are all constants. So when I integrate r squared, I do not get r cubed over 3. R squared is just a number. So when I integrate that, I get r squared times x. And then minus x cubed over 3 from h to r. Everybody good with that? Okay. We then get pi, and then we get r cubed minus r cubed over 3 minus r squared h minus h cubed over 3. And you can simplify some of this. You end up with pi times 2/3 r cubed minus r squared h minus h cubed over 3, which looks like they factored out a pi over 3, or factored out the 1/3 part of it all. So you take a 1/3 out of all of that, you're going to end up with 2r cubed minus 3r squared h plus h cubed, which looks like it's choice A. Good? Not good? Good?
How did it become plus h cubed?
Oh, sorry. It should have been a plus h cubed from the start.
Okay, thank you.
Minus the negative there. I must have just not written it there. Good or no? All right. Exciting. Y'all excited for the May 24th test? Just a week away. That's exciting. Pretty exciting. Any other questions on this section? If if you don't, we can move on to other things, but I'll make sure everybody gets a chance. Oh, okay. 45. Okay. .45, they give us a table. I'm going to write out the table real quick. 1, 2, 3, 4, and 5. We got 1.62, 4.15, 7.59, 12.13. Very exciting. Okay. It says a trapezoidal sum with n equals 4 is used to find the area under the curve from x equals 1 to x equals 5. I don't know why they'd have you round it to 2 decimals here, because that just is stupid, because the AP test always says you do it to 3, but that's fine. Anyway, since all of the subintervals here are equal, you can use the formula for the trapezoidal rule. Right? If the subintervals are not equal, you just have to find the area of each trapezoid separately. But since the subintervals 1 to 2, 2 to 3, 3 to 4, and 4 to 5 are all a length of 1, you can use the formula. Formula says b minus a over n. So end of your interval minus beginning of your interval divided by number of subintervals. That's b minus a over n, or we call this h, over 2. And then times the first y value. And then 2 times the next y value. And 2 times the next y value. And 2 times the next y value, all the way till you get to the last y value, which you do not multiply by 2. So you can just go straight through with the formula on that one. And I don't know what that all comes out to be. It must come out to be 27.53, because that's what the book says the answer is. But you're allowed a calculator on that one. So good. Other questions?
Could you show this one without using the formula? Like the subintervals were equal?
Say that again.
Could you show this one without using this formula? Like
oh, you didn't use the formula? Yeah.
Yeah.
So yeah, let me. So if you were going to not use the formula for this one, you would just find the area of each trapezoid, which would be 1.62 plus 4.15 divided by 2. So the average of the first 2 bases times the length of the subinterval, which is 1. And then same thing again, 4.15 plus 7.5 over 2 times 1, because the subinterval is again 1. Then you do 7.5 plus 9 over 2 times the length of that subinterval, which is again 1. And then you do 9 plus 12.13 divided by 2 times the length of that subinterval, which is also 1. Does that make sense?
Yeah, thank you.
And you just do the arithmetic on that. Good or no? All right, I'm gonna assume that's good. 17. All right, 17. They give us a graph here. Give us this section shaded in that region. Said this is y equals x cubed. And we've got a rectangle here. That's the point C, comma 0. We want to find the ratio of the area of the rectangle to the shaded part of it above the cubic. Okay, so In order to figure out the ratio of this area, we got to figure out the area of the rectangle. What's the area of the rectangle? It should be the length, which is C, times the height, which is C cubed. So what's the area of the rectangle? C to the 4. Then we need to figure out the area of the shaded region. Let's see what their answer choices look like and decide what a good way to do this is. What number was this thing? They're just simple little things. So in order to figure out the area of the the shaded region, we can do one of two things. We can either take the full rectangle and subtract the area underneath x cubed, or we can try to find the area between x cubed and the y-axis. So I think it probably is just, I don't know, we'll see if it works out. I think it'll work out just fine if we just do the rectangle, or the top piece of this here, and then subtract the cubic. That should be fine, right? So we'll integrate from 0 to c. What is our upper function up here? What is this function? What is this horizontal line? Y equals, not c, but y equals c cubed. So c cubed minus, and then minus x cubed. And remember that c is just a constant. We're integrating with respect to x. So this is going to become c cubed times x minus x to the 4th over 4 from 0 to c, which will give us c to the 4th minus 1/4 c to the 4th, which ought to be 3/4 c to the 4th. Everybody good with that? And then it asks for the ratio of the rectangle to the shaded part. So that ought to be c to the 4th to 3/4 c to the 4th. Well, the c to the 4ths are sort of insignificant. So this becomes 1 to 3/4, which is not what it has any answer choices, but you can just multiply by the 4 to make this 4 to 3, which looks like it's choice C. Everybody good with that? Question? Yeah, that was the shaded. I mean, the shaded region was the upper function, so that's this linear piece minus. Yeah. I mean, effectively, I did do the full rectangle minus this piece because the full rectangle was this c to the 4th. Yeah. You mean in terms of doing it in terms of x or y, or just? No, I mean, generally it's probably just better to do it. I mean, I don't know. It's not gonna matter because the integration of the linear piece is just going to turn into the exact area of that rectangle. So like, I would say that's pretty much as easy either way. 26. All right. The base of a solid is a circle of radius A. There it is. Every plane section perpendicular to a diameter is a square. Okay. So, oh, that's 25. Oh, the base of a solid. Oh, oops. Thank you. All right. The base of a solid is the region bounded by the parabola x squared equals 8y. So yeah, x squared equals 8y. That's 1/8 x squared, right? Y equals 1/8 x squared. So that's just some parabola that goes out like this. and the line y equals 4, so some line up here, y equals 4. That's the right one, right there. Each plane perpendicular to the y-axis is an equilateral triangle. So these are all equilateral triangles sticking straight out of that region. So hopefully you remember what is the area of an equilateral triangle. It is the, I told you guys to memorize this formula. What is the area of an equilateral triangle? S squared root 3 over 4. If you don't have that memorized, you should memorize that. It's helpful. S squared root 3 over 4. So that's the area of each of these. Since the triangles are perpendicular to the y-axis, we have to do the entire problem in terms of y, because what is the thickness of each of these little slices? It's in the y direction, right? They're infinitesimally thick in the y direction. So we got to do it in terms of y. So we need to figure out then what the length of one of these sides of these rectangles is in terms of y. So in order to do that, let's first figure out what it is in terms of x. What is this distance here in terms of x? Right. Well, this little distance here is just x, right? That's how far I've gone from the from the y-axis over to the point. That's x. And since this thing is symmetric across the x-axis, that whole symmetric against the y-axis, that whole distance is 2x. So the side length is 2x. So we've got 2x squared root 3 over 4, which becomes what? Just x squared root 3. Everybody good with that so far? But that's not what we want, right? Because we need it in terms of y. So what is x squared root 3 in terms of y? Yeah, 8y root 3, or 8 root 3 times y, or however you want to write it, right? X squared is equal to 8y. So then we need to integrate from the bottom of the parabola, which is 0, to the top of the parabola, which is 4. We'll put our 8 root 3 out in front, and we're just integrating y dy. Which looks like that gives us 64 root 3. Yeah. Choice B. Everybody good with that one? Nick, you good with that one?
Yes, I am.
Wonderful. Other questions? Yeah. Sure. Other questions? You guys seem really awake and excited to be here on this Monday morning. Yeah. 27, sure. All right, 27. The base of a solid is the region bounded by y equals e to the negative x. What does y equals e to the negative x look like? What does e to the x look like? E to the x just looks like that exponential function, but what does e to the negative x look like? Just a reflection of it over the y-axis, right? That's y equals e to the negative x. Let's see, what are we bounded by that? The x-axis, the y-axis, and x equals 1. Okay. And each cross-section perpendicular to the x-axis is a square. So we got squares coming out of here. What's the area of a square? Should be the side length squared. What is the thickness of each of these squares? dx. We got to do it all in terms of x. So we got to figure out what is the side length in terms of x. Well, what is the side length in terms of x? It's just y, right? It's y equals e to the negative x. And so that side length is just e to the negative x. So our area is e to the negative x squared, which is what? E to the negative 2x. So we will integrate from 0 to 1, e to the negative 2x dx. Good with that so far, Serena? Yeah. Then how do we integrate e to the negative 2x? U substitution. U equals negative 2x, du equals negative 1/2. We'll do that. Put negative 1/2 inside, negative 2 outside. There's negative 2 times an integral of e to the u du. And the integral 0 to 1 will become, well, if x is 0, u is still 0. But if x is 1, u is negative 2. Why did I put O? Yeah, negative 2. I don't know why I did that. Yeah. Wondering why you're starting to raise your hand, and I looked at it. I don't know. I put the negative 1/2 there because I was so excited about putting a negative 1/2 out in front, I guess. Anyway, still turns into this. Now we have a negative 1/2 out in front instead of a negative 2. That's much better. Yeah. Everybody good with that? I don't know why I did that. You good with that, Serena? Yeah. Okay. All right. So then we end up with, let's see, we could put the limits of integration if we want. You don't have to, but I'm going to. We have 1/2 integral from negative 2 to 0 of e to the u du, which gives us 1/2 of e to the 0. I guess I should write it. We'll say e to the u from negative 2 to 0, which gives us 1/2 e to the 0 minus e to the negative 2. And that becomes 1/2 of 1 minus 1 over e squared, which looks like that's choice E. Fitting, since the problem is all about E. Welcome back. Other questions? Are you good with that, Serena, or no? Yeah, yeah, good. I didn't plug the u back in because you don't have to do that with the definite integral. You can, if you change the limits of integration like you're supposed to, you can just leave them in terms of u and evaluate it that way. If you want to change this back to negative 2x, then that's fine. Then you got to change this back to 0 to 1 instead of negative 2 to 0. You end up with the same answer. But no reason to convert it back after you've already converted it. Other questions? Yeah.
I don't really like plug the u back in. Do I need to change my limits like at the beginning and then change them back? Or can I just use that?
Technically, yes, because when you write it all in terms of u, the implication is that those are u values. If you want to not change them, then you can just write, like, you know, if you were to do that, you could have just written x equals 0 and x equals 1 as the limits and not write in terms of u. That's fine, but just make sure you say that they're x values. Other questions? Everybody's good on that section now? I'm about to close my book and throw it on the ground. Once I do that, there's no going back. Y'all are good here? Y'all are good at home?
Yes.
All right, we're done. Not with everything. Actually, I asked you guys to do some pre-response questions too also, didn't I? No, I didn't. Oh, no. Did I ask you guys? I told you guys which ones we were going to do, though, right? Like, which type this week? Did I say miscellaneous? Is that what I said? I don't know. I just assume you guys listen when I talk and so that you do what I said to do. No? I didn't say miscellaneous. Did I say miscellaneous? I said miscellaneous? So you guys been working on those?
Your words are, I'm not going to assign any particular response questions to you guys to work on, but next week we're going to do it.
All right. Perfect. Let's do miscellaneous ones. Sounds great. All right. Let's see if I can figure out where they are on my laptop. I know where they are. Don't worry. Perfect. Miscellaneous A, B, F, R. Those are not the ones I want. Let's try this again. There we go. All right. What do you think? Should we start with this first one? Seems like a good place to start. You'll note that these ones, sometimes they're a little bit similar to other ones, but for the most part, they just kind of combine together different pieces of things that we've learned about throughout the year. Sometimes it'll be about finding derivatives. Sometimes it'll be about limits. I mean, it just varies. So none of the people at home can see that. Now you can see that at home, right? Yeah.
Yep.
Oh, good. All right. Cool. So I guess since you haven't done them yet, I'll give you a few minutes to work on it.
Is this calculator or non-calculator?
This is non-calculator. No calculator here. All right. 15 minutes. That seems reasonable. Great. 15 minutes it is. Ready, go. All right, part A, find h prime of 2. Okay, let's see here. What do we got here? The functions f, g, and h are twice differentiable. G of 2 is h of 2, which is 4. And then y equals 4 plus 2/3 times x minus 2 is tangent to both g and h at x equals 2. Well, if this line is tangent to h at x equals 2, then what is h prime of 2? H prime of 2, this is just the slope of the tangent line to h at x equals 2, isn't it? Which is 2/3, right? It's just the slope of this tangent line, which they gave you 1 point for that. Everybody good with that? A should have been pretty easy. All right, for B, they gave us a new function a of x, which is 3x cubed h of x. We want to write an expression for a prime and then find a prime at 2. So a prime of x, how do we find a prime of x for a function that is 3x cubed times h of x? Exactly, product rule, right? 9x squared h of x plus 3x cubed h prime of x, right? Derivative of 3x cubed times h of x plus 3x cubed times the derivative of h. Everybody good with that? Just the expression, actually, that was worth 2 full points if you just found what a prime of x was. And then to find a prime of 2, just plug in 2. So what is that going to become here? It's going to be 2 squared is 4 times 9 is 36. 36 times h of 2, which they gave us, which we'll put in a second. And then this becomes 24. 2 cubed is 8 times the 3 is 24. And then h prime of 2. And we have h of 2. H of 2 is 4. And h prime of 2 was 2/3. So we just have 36 times 4 plus 24 times 2/3, which came out to be, what did that come out to be? 160? Did I multiply right in my head? according to the scoring guidelines I did. And that was worth 1 point. Everybody good there? Any questions on A or B? Everyone feels okay about that? All right. Part C. The function h satisfies this. H of x is x squared minus 4 over 1 minus f of x cubed for x not equal to 2. We know that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Okay, before we even worry about what it's asking down here, if we know that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule, what does that tell you about both the numerator and the denominator of h of x when you plug in 2? They're both 0. Clearly the numerator is 0, right? So, but that tells us that 1 minus f of x cubed is equal to 0. Chances are we're going to need that information. I'm just going to write it down here just so that we have it there. We know that that must be true based on they told us we could use L'Hopital's rule to evaluate this limit. So then they say, all right, find f of 2 and find f prime of 2 using the limit as x approaches 2 of h of x. So, well, we know that 1 minus f of x cubed equals 0, like we said, at x equals 2. So if we're looking for f of 2, we should be able to solve this for f of 2, shouldn't we? 1 minus f of 2 cubed is 0, or f of 2 cubed is 1, or f of 2 is 1. Everybody good with that? That was worth 2 points. No, that was worth 1 point. That was worth 1 point. Okay. Then, let's see, what else does it ask us to find? F prime of 2. So we know that, we know a couple things. One, that we need to use L'Hopital's rule to evaluate this. So we're going to say using L'Hopital's rule, you'll write it all the way out. We're going to have the limit as x approaches 2 of what was the derivative of the numerator? That'd just be 2x. And the derivative of the denominator, the 1 goes away. We're taking the derivative of negative f of x cubed. So that should become negative 3 f of x squared times f prime of x. Everybody good with that? This is worth 1 point. And then we need to have something to set this equal to, don't we? What is this equal? It equals 4. Why does it equal 4? Well, because we know that, where is it? Where did it go? Oh, because no, that's not why. G of 2 and h of 2 is 4 is not the reason why. What did it say? It said it in here somewhere. Where is it? Oh yeah, no, it does. H of x, right, there we go. H of x is this. So h of 2 is 4. So there we go. We know that it must be because it's twice differentiable. Sorry, that's my fault for not reading properly. For some reason, I was thinking this was saying f of x. So h of 2 is 4, right? And so h of 2 is 4, which means that the limit as h approaches 2 is got to be 4, or as x approaches 2 of h, it's got to be 4 because the function is differentiable, which means it's continuous. So we set that all equal to 4. Setting it equal to 4 is worth another point. And then solving that is worth the final point. So we already found f of 2. We're going to plug in our 2. So 2 times 2 over all this other junk is going to equal 4. Negative 3. F of 2 was what? We just found that. That was 1, right? So 1 squared. And then f prime of 2, which is what we're looking for. And we'll just cross multiply. Yeah, question? That's the chain rule. Taking the derivative of 1 minus f of x cubed So that's 1 minus u cubed. That's negative u cubed effectively, right? 1 minus u cubed. So with u equal to f of x. So it's negative 3u squared times f prime of x. All right, so then we're going to multiply this all through. So we're going to have 4 equals, and this is going to become a negative 12 f prime of 2. And we'll divide by the negative 12, which will give us f prime of 2 on the right. And on this side, it should give us negative 1/3. And that was worth 1 more point. We're getting there. So 4 points for part C. Everybody good there? No questions? Everyone's good? Part D says it is known that g of x is less than or equal to h of x for 1 to 3, and that k is a function that is sandwiched between g and h, right, or squeezed between them. We want to know, is k continuous at x equals 2? Right, so how are we going to determine if k is continuous at x equals 2? Okay, first off, we know that we don't care about f. We know that g and h are both twice differentiable, right? So g and h are twice differentiable, which means they're both continuous. Right? They can't be differentiable if they're not continuous. So that's a start here. We know that those ones are continuous. If those are continuous and k has got to be between them, and those limits are both equal to 2, what does that tell us? If these limits are both equal to 2, then the limit as x approaches 2 of k of x has to equal 2. Function h satisfies. Yeah, it satisfies this for all x values that are not 2. Yeah, so that's okay, as long as the value at, it still tells us the value at 2 is 4. So it's approaching 2. That tells us that this limit is equal to 2 as we approach, or sorry, the limit is equal to 4 as we approach 2 for h. Just because it's not defined by the same function when it's less than 2 and when it's greater than 2 as it is when it's at 2, it doesn't mean that it's still not, it doesn't mean that it's not necessarily continuous at 2, right? Because we can have a point that fills that in, as long as we're approaching it from both sides and as long as that point exists. Right, that's the definition of continuity, right? The definition of continuity is that the limit has to exist, right? So the limit exists. The value of the function must exist. And those two things must be the same. So as long as those 3 criteria are met, the function is continuous at that point. Yeah. Oh, sorry, it's 4, huh? They both said 4. That's my fault. I keep getting the 2s and the 4s mixed up, right? 4? Yeah, they equal 4. Limit is 4 because the value of both of those other functions is 4. And this one is sandwiched between them. So we can go through and we can say, and this is by the sandwich theorem or by the squeeze theorem. And since we know that k is always less than or equal to h and greater than or equal to g on this interval, it's always sandwiched between them. Just based on this basic definition here, that if this is between those two, that means that those values must exist surrounding it, right? So therefore, since the squeeze theorem applies, this tells us that it must be continuous at x equals 2 as well. And that was worth 1 point. So we know that these are continuous, and since they're continuous and k exists for all those same values. It must be continuous at all the points except maybe at 2. The squeeze theorem tells us that the limit at 2 is 4, which means that it must be continuous at 2 because all of those things match up. Does that make sense to everybody? No points if you don't have the right explanation. Yeah. Yeah. And I'm surprised that's only worth, I mean, I'm sort of surprised that that's only worth 1 point because they require a lot of explanation for that one. But yeah. Nope, you wouldn't get it unless you had all the explanation. Any other questions on that one? All right. For tomorrow, let's see here. I'm not a fan of the tree problem. It's fine, I guess, but let's have you guys do number, let's see. This one's number 3 originally. So we're going to do 3, 4, and 5 for tomorrow. 3, 4, and 5. About a tank, this graph looking thing, and this chart looking thing. 3, 4, and 5. The other thing I wanted to tell you guys, actually, let me